So folks may have seen this quote. Werner Vogel's the CTO of Amazon, gave this quote in an interview in 2006, so it's been, what, 12 years ago now. Says, you build it, you run it. You saw a little bit about it this morning, the 2 pizza teams, et cetera, where the same people that build the software at Amazon are expected actually to run that same software in production. Same year, in 2006, 3 folks who used to work for us at the time did a white paper at Agile 2006 called the Software Production Line, which then became the Continuous Delivery books. That was Jez Humble and Chris Reed and Dan North. That book came out, I think, in about 2010. DevOpsDays started in 2009. I think everybody's heard several times by now. It's where the term DevOps came from. And we look at these things, all these things that happen, and we're like, why? What was the driver? I can tell you that at ThoughtWorks, with continuous delivery at least, we saw this as the last mile of Agile. We thought of fulfilling the Agile promise. That's actually where the term continuous delivery came from the Agile Manifesto. And a lot of people then said, oh, well, okay, so DevOps means I don't have to have operations people anymore. I don't have to have systems anymore, and everything's going to be magic. What's funny, though, is if you look at the entire article, and I'm not going to show you the whole thing, the entire article from Werner's quote, the reason that they did this is because they wanted to bring the development teams into closer contact with the end user customer. It's the reason that we did a lot of our early continuous delivery work as well. Things like the A/B testing that you heard about this morning, and measuring the effectiveness of software, and getting prototypes out into the hands of users, and things like that. That's why we have you build it, you run it. That's why we want continuous delivery. That's why we want fast response and so forth. It's actually not about cost savings or not having operations or using the cloud or all the other magic things. So there's a lot that goes into it. So the longer title that's in your agenda of this talk is actually, you only have to change one thing to do the DevOps. Because I see people all the time that like, okay, I'm going to take everything I have and automate it. Or I'm not going to change anything about my architecture, but I'm going to come up with new words or what have you. So yeah, you only have to change one thing, but the catch is it's everything. Okay, because this really is, it has to be a holistic thing. You can't just change one part and operate everything else the way it's supposed to be or was and expect massive change. Sometimes you'd have to be disruptive in this world. So the good old spoiler slide that we're going to go through here, some of the changes I'm going to try to encourage you to do is first making sure you're defining these terms so that you agree, at least inside your organization, what these different things mean. It might be organizational change. The 2 pizza team type thing. You may need to re-architect some of your software. And the point of continuous delivery isn't actually just to get stuff out there faster, it's to get out there safely. So we're going to talk a little bit about that. So for anyone who saw the bit of lightning talk yesterday, you already know this part. I work for ThoughtWorks. I'm from Seattle. Nice, just short trip here. I teach continuous delivery and DevOps for ThoughtWorks. Been about 10 years. I'm one of the DevOpsDays core organizers. There's one of your 3 Twitter people, if you want to. Reach out. Okay, so when I talk about defining words, now I'm going to go through this, and I want to say I'm going to show you some things that I don't think DevOps is. I'm going to show you things I think DevOps isn't and is, and et cetera. It's not important that you agree with me. It's important that you know what I mean when I say the words for the rest of this presentation, so that you understand the context. Otherwise, the whole thing gets misconstrued, right? And I think the same thing is true inside your organization. I'm going to show you my definition of DevOps because the original founders, Stephen and Patrick and et cetera, didn't define it on purpose because they want you to have your own. So I'm going to show you my definition. Come up with your own if you'd like, but put it on the wall so that in your teams, and when you say the words, people mean the same thing. If you want to call it a DevOps pipeline, please don't do it in front of me, but that's okay as people know what you're doing to do it. Okay, so first off, what isn't DevOps? It's not a tool set. Okay, so if you need better monitoring, by all means, get a better monitoring tool. If you need better continuous delivery pipelines, get a pipeline tool. There's no DevOps tool. Okay, it's still logging. Okay, the cloud is still computers. Get the thing you need and don't be caught up in there too much. Apologies to those with the title of DevOps engineer, but it's also not supposed to be a role. Now, this is reality, though. If I want to hire a person with a certain skill set, or if I'm that person and I want to find a job, what you're going to Google for is DevOps engineer. That's the reality. But in the implementation, please don't think of it as an individual that's responsible for doing the DevOps. And I'll get a lot more into this one. I also don't think it's a team. I'm not a big fan of the whole idea of a DevOps team. One thing that helps me in this is don't think of DevOps as developers and operators, the nouns, because what about UX and marketing and sales and okay, think about it as the verbs, developing and operating. So it's the people that are involved in developing and operating software, systems, etc. So that means it is security, it is compliance, it is UX, it is all the kinds of testing, etc. One of the older things that came out for defining DevOps was this thing, CAMS. John Willis was another one of the 50 people at the first one. He's the one that brought it back to the US, brought DevOps Days back to the US. And he came up with an acronym that's very commonly used. I like it a lot. Culture, automation, measurement, and sharing. The blog entry is there, it's from 2010. Please do go ahead and read it. Most people don't really think of only the automation. Okay, but measurement, the A/B testing, is what we're deploying actually effective. Sharing, coming to here, and hey, how do you do the Kubernetes? That kind of thing is also very important to it. Jez Humble, who co-wrote Lean Enterprise and Continuous Delivery, likes to stick Lean in the middle. I will tell you that most of the organizations I see that do effective continuous delivery, meaning deploy on demand and that kind of thing, are not using iterative development. They're using more things like lean flow and work in progress, etc. Okay, this is my definition of DevOps. Again, notice that it says culture there. It doesn't say automation. I work for a consulting company that makes a continuous delivery tool. It doesn't say continuous delivery. It's a culture of people working together. Okay, so that's what's important, to have all the viewpoints and so forth. Again, on the blog there's a detailed description of what that means, but this is what I mean when I say it. So often, to get to this thing does mean changing your organization. I just said it's a team of people that are, it's cross-platform or cross-talent, whatever you want to call it. So a lot of times this means organizational change. In fact, if you really only did change one thing, it's probably your org. It's probably not your software. It's definitely not your tools. So what we want to do is look at the traditional model. If anyone's ever taken Agile 101 training, some of this is from courses that we were doing, us old people, like 15, 20 years ago. You have your development teams and you have your testing team, and that could be compliance, could be security, call it whatever you want. And the operations team, and in between them there are the walls. And these are really like communication buffers. We want to make sure that we don't understand each other because that would be bad. We wouldn't want to know what's actually happening. And they don't talk to each other. They don't know why. I loved that some of the talks this morning and yesterday both talked about the why. Why are we doing this thing? What is the goal? Et cetera. I can't believe, I think I'm actually the first one at this DevOps Days, which is really rare on day 2, to use Conway's Law, which is this. Basically, it's saying that your system's going to end up mirroring your organizational structure. This paper was originally written 50 years ago. So Mel wasn't really talking about software systems. They were talking about infrastructure and so forth. But it is true. If you have an organization inside your a team inside your organization that's responsible for credit cards, you're going to have a module that does credit cards, or component, or service, or what have you. And so we go back to our traditional model here. Now, only going to be a very slight change on the slide. Renaming operations team to DevOps team does not solve the problem. Okay, sorry. Now I know that there's different skill sets. We're going to know Amazon and Google Cloud, et cetera. But it's really not just the same thing with a different name. That's not the goal. By the same token, they're going to be toward the end of the talk talking about platforms, which is an exception to this, but I'm also not a fan of the DevOps team that creates the automation that everybody else uses. Because what does this do? This solves the A in CAMS or comms, the automation, but it doesn't solve culture, measurement, sharing, et cetera. The operations people who are getting paged at 3 in the morning because the system's down still don't know why the system's tried to do that. Okay, the people that are doing the testing don't know exactly what's going on. The compliance people don't know what systems you touched, et cetera. So it doesn't solve any of the communication gaps. It might solve the automation, but it won't solve the communication. And so this is where we start encouraging product teams. So this is the Amazon 2-pizza team. And American pizzas are really big, so I don't know how big these pizzas are. But, but the idea here is products over projects. And you'll see that everywhere. There's a thing on our chief scientist, Martin Fowler, has a big blog on it. The founder of TaskTop just wrote a book on it, et cetera. It's the idea of having a product team that is a long-running thing. It's not a project with a start and end date. They own the thing. And I'll get into more of what that means as we go along. Because what this enables is modern architectures and technologies. One of the biggest things that we hear, at least at ThoughtWorks in our continuous delivery work, is, well, that's great if you're a startup and you're, doing microservices or whatever, but, we're got this big thing and we're, et cetera. Well, Hewlett-Packard did continuous delivery on their printers. They managed to find a way where instead of having to physically test each one, they could do CD on printer firmware. They didn't do it by developing a better pipeline. They did it by rewriting the software that ran on the firmware. Took advantage of the fact that technology has changed and so forth. So they actually had to change their product in order to do this. But it went from where they were spending the vast majority of their time doing maintenance to spending the majority of their time doing new product features, because now they could deliver faster and test and so forth. And so if you do have a big legacy monolith, yeah, just putting a pipeline on it, putting Jenkins underneath it probably isn't going to work. They can be hard. So a customer we had is a travel company, and typical monolith, all functionalities in one process. They were fairly early in a web-based travel company in the late 90s, is when they first started. And so they had this massive monolith. And when we first got there, we're saying, okay, so what's your deployment schedule now? We deploy once a week. And well, that's incredibly good for what you are and where this was a few years ago, et cetera. You're like, yeah, but it's the build that was done 6 months ago. It's like, oh, okay, never mind. So their time to market, they might take 3 hours to change the feature, but it was 6 months plus a week to actually get it to customers. So they were very, very, very slow to respond. The same token, when they had to scale things, they had to scale the entire application. So like rental cars, that's a really big thing in the United States. We have horrible public transit. It's a very large country. People rent a car and they drive 3 hours instead of using other methods. Other countries, rental cars aren't a big deal. But if I wanted to make more rental car availability for Seattle, where I live, I also had to scale rental car availability for London, where nobody hires a car. Okay, so they're paying for infrastructure they're not using. So it's not only time to market, but also just scaling of the application itself. And so, buzzword time, that's why they switched over to microservices. So in this case, what they're trying to do is solve this distinct problem. So Sam Newman wrote a book called Building Microservices, and he says greenfield is actually not where you start. So I'm not saying microservice first, because you don't know your business boundaries yet, necessarily. So I'm not saying this is the end all, but in this case, they know their business boundaries really well, and they have a particular pain. And so what they want to do is bring out each element of functionality into a separate service. But they started with the one where they were having the most problem, the one that they needed to scale, that they couldn't scale because, okay, et cetera. In this case, it was hotel pricing, because there's always sales and ads coming up, and there's weather in this country, so this country changes. I mean, it's amazing how often these things change. So they didn't decompose the entire monolith. They didn't rewrite the whole thing. They created a new microservice only for that. And when it got to an MVP, or minimum viable process, they went to the monolith and they changed the calls over to the service. Now that service could be deployed on its own as fast as they needed to. They could do A/B testing. It was funny to hear the stories, because the color of the button, the hue of the color makes a difference. So they would A/B test of this hue of green versus that hue of green, and see which one made reservations go up and see which one made reservations go down. This company no longer does, now, I mean, this is years ago, now most of it's decomposed. They no longer do really detailed feature analysis. The teams, one owner, just like I'm sorry, I forgot his name from Twitch, talking about they have a product owner on each of these teams. They come up with a theory, they write code to test the theory, they deploy the code to test the theory, and if the reservations go up, they roll it out. If they go down, they take it back. They A/B test everything. And they can only do that by changing the architecture. There's no way with their existing architecture they could have gone through and reached these goals. And so we go back to our product teams, and this is what they come up with. So there's a team that owns rental cars, there's a team that owns hotels, et cetera. And of course, there's a lot more than this and so forth, and they own more than one. There's a life cycle involved here. But the idea is that they know their business really well. And so they were able to hire line of business managers for like the rental car team that knows about the rental car market, and they know which countries they're in and which specialties are going to work, and et cetera. And so it really allowed them to do really good things. Now, homework, because in a 30 or 40-minute talk, can't do a thing. Full disclosure, I think all of the books, if not all, are written by current or former ThoughtWorks people, so bias. But building evolutionary architectures is actually not about microservices. It's about building your software in a way that you can do what's next year, that we don't know yet. So building it so it can evolve. And then, of course, building microservices by Sam Newman. We still have to deploy somewhere. It's actually not magic. Okay, and this is where the whole platform thing is going to start coming in. So first off, I want to try to differentiate. This is probably going to be old school because this slide's a few years old now. Everybody here might be aware of this, but still, as I mentioned earlier, I think it's important that we agree on terms, or at least that you understand what I'm saying. So when I talk about the different levels of service, okay, on premises, download the software, run it on, so you're the same as buying a car, basically. At least in the way that finance stuff works in the US, every part of that car is now my responsibility. If it gets destroyed, I have to have insurance for it, or I just lose. I have to do all the maintenance, et cetera. Infrastructure as a service, we have a concept, I don't know if you have it here, called leasing a car, where it's basically like a long-term rental. Okay, so the car and the finance and depreciation are taken over by the leasing company. I bought an electric car, or leased an electric car a few years ago because I didn't want to take the depreciation on a lease, on an electric car. And when I turned it back into the bank about a year ago, it was worth half of what it would have been, I would have been able to sell it for. And so that was good for me. Platform as a service is basically like if you hire car hire or rental car. So I go to Hertz or whatever and I rent a car. I'm responsible for the fuel and I have to drive it and the road tolls. But for the most part, the rental company is going to take care of everything else. They're hopefully going to make sure it's in good working order. It's their problem if it depreciates. It's their problem to replace the tires. In most cases, if you rent a sports car and tear them up, I find out they charge you for that. But anyway. And then, of course, software as a service is the taxi. I just get in the car and go. So what I want to talk about today is platform as a service. I believe this is an incredibly enabling concept. So the example I'm going to use, because there's a joke, what do you call someone that only speaks one language? An American? All my examples are also American, but the example I'm going to use is an organization called cloud.gov. Now in the United States, if you're a government agency and you want to run software on the public cloud, so if you want to run it on Azure or Amazon or name your company, there's a whole bunch of regulations that you have to comply with, security checks, etc. And it's very, very hard. And so some folks got together and created cloud.gov. Now, cloud.gov is actually an official service of the US government. So there's 325 security controls. 269 of them are handled by cloud.gov. So is DNS properly configured? Are our routing tables not writable? Or security patches for the operating system? All of those kinds of things now become the responsibility of cloud.gov. So if I'm that government organization and I want to build an application, I now have 15 that are solely my responsibility. Password policies, stuff like that. 41 that are shared. So there's 41 of them where my application is going to change the way their thing works, et cetera. But my ability to deploy to the public cloud just got substantially easier. And on my product team, I no longer have to have someone who knows the deep internals of the operating system because cloud.gov has them. Okay, so it shifts some of that responsibility out. Now, that said, surprise, serverless has servers. Okay, it is just somebody else's computer. And so that's what I mean, there is still somebody that has to know how to do that. It might be somebody you're paying, it might be cloud.gov or Azure or whoever. So if we go back to our product teams, a lot of times when I start this presentation, especially if I'm in an operations heavy conference, people see this where they're going to get put on a product team. Some of the folks I'm old school operations. I mean, I am literally old school, where I racked, workstations. I had a Spark 5. We were talking about that earlier. They're like, I don't want to do that. I don't want to be on a product team. That's not what I signed up for. You don't necessarily have to be. Somebody has to run that platform. Okay? Our product teams that are deploying to things like Kubernetes know something about Kubernetes, but they're not experts. The people on the platform team are. So the platform team is also a product team. Their product is the platform. So the development teams are like, I need to be able to run on Google Cloud. Okay, we're going to provide that as a platform. Because what? Okay, or I need internal, I need OpenShift, I need whatever it has. They become a product team, and their customer is the development team. Now that platform team is responsible for those 269 things in the case of cloud.gov. I don't want to assume that this is public cloud, like I said. So this might still be internal. This might be VMware. Or this could be physical hardware, whatever it is. But you come up with a standard that says, we will support your application if you meet these things. And you make that available to folks. I wish we could put compliance people on every team. Well, I kind of do and I kind of don't, because auditors are interested. Yeah, but you can't, so they're still going to be there. And please security test your stuff as a credit card holder, please. Okay, so there still are other teams that you're not going to really get. I mean, security is everybody's job, for example, but there are still going to be. I have a good friend who is a white hat hacker who I want him sitting in a dark room trying to hack my stuff, because I'm not going to think about it, and not everything here can be automated, etc. Okay, so if I have this kind of org structure, where does this come in? So continuous delivery. This is what I mean by change everything. This is all intertwined. So Jez Hummel and Dave Farley, they wrote a book called Continuous Delivery. That's Jez's definition of continuous delivery. So a couple key things here to me is that it's changes of all types. So it is new features, configuration, read up on 12-factor apps, that kind of thing. Bug fixes, experiments, the A/B tests, the different colors of green, etc. It's all of those changes into production or the hand of users safely and quickly in a sustainable way. So he doesn't say cheaper. Okay, he does say quickly, but he doesn't necessarily say faster. But it is more about deploy on demand. Now it's funny because when they were trying to write the book, if you caught what I said at the beginning, the white paper that read to the book was called the software production line. But when they were coming up with a title for the book, they're like, okay, what's it going to be? So everybody familiar with the Agile Manifesto? We value this over that. Okay. There's a page 2 that is the principles behind the Agile Manifesto. And the first one is the early and continuous delivery of valuable software to our users. So that's where the term continuous delivery came from, is it's the fulfillment of Agile, of delivering software to the users as opposed to the product manager. And that is the book. One of the ways I like to think of it is CD is what you do as part of a DevOps culture. So when I say there's no such thing as a DevOps pipeline, I think there's a continuous delivery pipeline. You can do continuous delivery, you can't do DevOps. Like many things, there is a prerequisite. Continuous integration and continuous delivery are not the same thing. It is a superset. We can do open space if we want to go into it. But we have a thing that we do at ThoughtWorks called the Tech Radar, where we put out learnings. We're about 5,000 people globally, different things that we've learned on different projects and so forth. And one of the things that we see a lot is this anti-pattern that we call CI theater. So, I say I'm doing CI, but I'm not really. Okay, so, actually there's one here. There we go. This was my, I don't know, favorite, least favorite? Can't decide. We did a study, followed it up. Yeah, 90% of the people thought that downloading Jenkins was the same as doing continuous integration. Or Go CD. I mean, I'll use my own. I shouldn't, okay, not just pick on CloudBees. Please, feel free, it's open source. Download Go CD, have fun. That's not the same as doing the thing. Okay, that's the tool, that's the hammer. You still have to do the practices. Jez and Martin Fowler, our chief scientist, wrote this continuous integration certification test. So every developer committing to a shared mainline, call it trunk, call it master, whatever you want. We believe that if you're doing long-lived feature branches, that you're not doing continuous integration, full stop. Okay, you might be doing really good automated build and test, but it's not CI. Every commit triggers that automated build and test. And if the build and test fails, it's repaired within 10 minutes. So again, you have a small team, somebody did a push, every build's running on every push, it fails, hey, stop, why did it fail? Let's fix it. It's absolutely okay to break the build. Please don't do the dunce cap thing or whatever when people break the build. That's the job of the continuous integration, continuous delivery server. Okay, but you have to fix it right away. Don't leave it red. Flaky tests to me are worse than no test, because I don't really know when I have an actual failure. So that's the flow, if you will. So I check some code in, it runs some fast tests. That's labeled build and unit, but really the point is they're the fastest ones. If they fail, the team fixes it. Now it goes a little bit further and a little bit further and a little bit further. I don't think I have a slide for this, but I like to say, let's down here where it says like the user acceptance, what have you. So that's like a product manager saying, yep, it's ready. I want to differentiate between continuous delivery and continuous deployment. Continuous delivery is that you can deploy anytime you want. So the continuous delivery is the ability to deploy at any time. Somebody makes a decision to click a button that does a deployment. Continuous deployment is fully automated. If all the tests pass, then it gets into production. Kind of like the story that we heard in one of the keynotes there of sending out a new version of Slack every week to on-site enterprise users. GoCD is on-premises software. We do several builds a day, but we don't, thank you very much. We do several builds a day, but we don't ship them all. Because if you wouldn't want to update your continuous delivery server several times a day, right? So we do continuous delivery. We deploy to production roughly once a month. But you can log into the build server and get anyone you want. SaaS products, though, will deploy several times a day. So the fonts, when we turned in the things got a little bit off, but sorry, this is my snide part. There is more to it, and I'm going to go into some of that. I already went through this. I did have the slide for CD versus CD. Okay, so back to our teams. So we have product teams, security teams, compliance teams. What are their roles in all of this? I really strongly want to give the product teams access to production. I want them to be able to make a change, and if that change passes all the tests, to show up in production automatically. So that they can get that fast feedback and they can know, was that the right shade of green? Okay, it's really important, but it rightfully scares the heck out of people because there's some things that are bad. Deploying insecure software is bad. Okay, non-performant software is actually really bad in today's world. If your website's slower than somebody else's, they're gone. Non-compliance, these days, at least in the US, you can go to jail over this stuff if you're doing things overtly out of compliance. But, as was mentioned earlier, ineffective software, deploying something that makes our sales get worse. I want to know about that before I spend a lot of time on the feature. So I don't want to do any of these things, and it's the job of the pipeline to protect me from that. This is my safety net. Okay, so the purpose of a CD pipeline is to kill a release candidate. It is its only purpose. Every time I commit to a change, that is a release candidate. It's the pipeline's job to prove it's not good enough. I can't prove something's good. I can make it green all the time, just not by running any tests, okay? But I can prove something's bad. I can know that I have something that has a security bulletin posted against it. I can't know that it's secure, but I can definitely know that it's insecure, okay? And that's the pipeline's job. And so this is where continuous delivery starts to separate itself from continuous integration. It's very easy to run things in parallel on a CI server. This is Chrome, and this is Firefox, and this is, well, I guess you don't have to do Edge anymore. Yeah. But what about entirely different kind of things that have entirely different lengths of runtime and entirely different expertise, et cetera? So what I want to encourage you to do, and every tool out, this is not a tool thing, every tool out there can do this, is, let's say I have a Java project and I build a jar. When that jar is available, yes, let the development team run it through their pipeline, run their functional test, deploy to a staging environment, whatever that pattern is. But at the same time, let's pull that jar out and run it through a bunch of security tests. Let's make sure that it's not using things that there's known vulnerabilities. Let's make sure that it's not exposing a port it's not supposed to. Let's do all that. Compliance tests. Let's run server spec against it. Let's run inspec against it, et cetera. Notice I'm not putting these in linear fashion. If you ask the authors of the CD book, they say their number one mistake was putting the diagrams of CD pipelines very linear. I want to do these in parallel because I'm not going to slow down the development team but I am going to gate them. The arrows here are not just there for no reason. They're there on purpose. I can get all the way to staging without those bottom two finishing or passing, or wherever makes the right point for you. If your staging is on your production network, then don't do this, okay? But I want the development team to get feedback from their unit tests and their functional tests as often as possible. In this diagram, the purpose of the staging department, or stage, is to test the deployment. So staging looks like production, maybe not the same number of servers, but same kind of setup. I want to test deployment to a production-like environment as often as possible. And so I'm going to let that all happen, but I'm not going to let it go to production if any of the security tests fail. So that's where that dependency comes in. And again, a lot of times these folks have different expertise. Security is everybody's job, but they may be running things that just you can't put on every team. I mean, that is the reality, unfortunately, of the world. You can't put these people on every team. And also, there's a thing called unconscious bias. I don't necessarily want the dev team to know everything that I'm going to check. Okay? Now, I'm not saying obfuscate things for the sake of obfuscation, but these are different things, and I need to be able to go back to them and show them, hey, I did this OWASP report using these things. These are the vulnerabilities that came out. Let's talk about the risk, et cetera. Okay, but that's your pipeline's job, is to prove these things aren't good enough. Okay, sorry, no silver bullet. So, I mean, that's kind of the thing is after 10 years of ThoughtWorks, like I said, I've seen people, and not just our products, with other CI/CD servers, whatever, they get an automation thing, or they get Chef, or they get Puppet, or they get a tool of some sort, or they change just something about their architecture, but they don't change the way the organization works, et cetera. And most of the time, they fail. You're like, yeah, DevOps doesn't work. Just like we say Agile didn't work. We stood up for our meetings, but it didn't work. Okay, there's actually a little more to it than that, but we would often see that. So there's not a silver bullet, but these are solved problems for the most part. So a couple books that I like to recommend. DevOps Handbook is a bunch of stories. Accelerate is actually the science behind the State of DevOps report, if you haven't read that. I really like the Phoenix Project. If you haven't read that, it's fictional, but it's a couple-hour read. It's real easy, and it goes through some of these things. And then, with all due respect to the lightning talk yesterday, there's a coworker wrote a book called Infrastructure as Code, but it does help automate some of these deployments and so forth. And so the summary here is you need to have good definitions of what these things mean inside your organization. Again, it's not important that you agree with mine. It's not important that you agree with each other's. Okay, but inside your organization, if somebody says, did you do the functional testing, you need to know what that meant. Okay, if they say, did you create the pipeline, if you have a template, you didn't know what that means. Org change, if you did only have to change one thing, is most likely. The modern architectures and technologies, please don't just go rewrite all your software because microservices are cool. Here's a Charity Majors, I think, came out with a thing. It said, I decomposed my monolith into microservices, and now every outage is a murder mystery. Okay, they are harder to check. Distributed applications are hard. Somebody says they're really good at distributed applications is lying. Okay, so don't do it just to do it, but do it where you're going to get some benefit from it. And again, use your CD pipeline to give you that safety net. This is where your tests are. This is when you prove the software is not good enough. Thank you. I guess we have a couple minutes if there's any questions. This is where I get to stand up here and go, gosh, I hope there's, is that, were you just waving to him, or is there a question? He just bought it, so $5 going once, yeah.
You mentioned that you proposed the DevOps team concept. Later on, you presented the platform team concept. And they're kind of like in some companies, what you described as a platform team would be the DevOps.
Yeah, and that's why I said when I said DevOps teams is the anti-pattern, I said, but I'm going to talk later about platforms. If you want to do a continuous integration server or a continuous delivery server as a platform, so CI/CD as a service to your dev teams, by all means. Okay, but please let them control their pipeline. That's the other advantage of running other pipelines in parallel, is you can say, look, mobile apps have different requirements than a CRM app, which has different requirements than a Windows app. And so you can describe your pipeline, but know that as soon as you get a build artifact, I'm going to suck it out into my pipelines and run it through compliance, and, et cetera. But I want them to know how it got to production and why it got to production, and I want them to get the phone call when it goes down. I don't want the DevOps team to get the phone call when it goes down. And so, yeah, if you want to provide the server as a platform, cool. But don't create their pipelines where they just now don't know what's going on. And so they still don't really understand when I change something, if you go to the blog entry on my definition of DevOps, the story I tell is one where ThoughtWorks project 10 or 11 years ago, that failed miserably because the team writing the software didn't know anything about Solaris, and they did something that wouldn't work on NFS. If they had a Solaris admin there, just a member of the team, never would have happened. Yep. Yeah.
Small one. Can you give some sort of a definition of an ideal team structure?
Definition of an ideal team structure? No, I cannot. I mean, really, it's highly dependent on architecture and things like that. Okay, but let's say in that Java project, they were running a Java project. The deployment target was going to be Solaris. They knew that up front. But the machines they were issued were Windows laptops. This is 05, 06. We all know Java runs exactly the same everywhere. And so they're like, oh yeah, that'll be no problem. They should have had a Solaris admin. But if the deployment target had been Windows, yeah, no big deal. Okay, so you want to have at least some knowledge about the different things. There's the idea of a T-shaped engineer. Someone knows a little bit about things and a lot about so forth. You really want to have some knowledge on the team that is, how your architecture works, what your deployment targets are, why you're doing those things are, what your risk points are. So your compliance is going to be a lot easier if you can explain to the auditors, these are the internal systems we're touching, this is the kind of customer data we're gathering, et cetera. Oh, okay, then I only have to audit these 12 points instead of these 400. So a good understanding of that is pretty important, but it varies wildly. Okay, thank you very much.